Welcome back to Physics for All YouTube channel. In this session, I am going to explain you about expression for intrinsic conductivity in intrinsic semiconductor. Okay. Now, in order to derive equation for the intrinsic conductivity, consider an intrinsic semiconductor. First of all, we had consider intrinsic semiconductor. Okay. Now, this is a intrinsic semiconductor. Okay, now inside of this semiconductor it contains number of holes which are represented by red color circles. Now in addition to the holes, it also contains number of free electrons. Okay, so these are known as free electrons. From the previous discussion already we know that in intrinsic semiconductor always there is equal number of free electrons and holes. Okay, now when there is no voltage applied to that semiconductor, then all the charge carriers, that is free electrons and holes, are moving randomly from one side to the other side. Now to know about equation for the intrinsic conductivity, let us consider this is semiconductor to some external electric field. Now I am going to apply some electric field externally. Okay, now capital E is the electric field applied to the intrinsic semiconductor. Okay, now because of applied electric field inside of the semiconductor, it contains number of holes and number of electrons. Okay, already we know that holes are having positive charge and electrons are having negative charge. Okay, these holes are repelled by the positive supply of the battery, then all holes are moving towards in this direction. Similarly, inside of the same intrinsic semiconductor, it contains a number of free electrons which are having negative charge. These electrons also repelled by the negative supply of the applied electric field, then these electrons are traveling in this direction. So whenever electrons and holes are traveling from one side to another side in a particular direction, what we can get, all electrons and holes are traveling in a particular direction because of the applied electric field. This phenomenon is known as drift. Okay, now due to the drift of electrons and holes, what we can say here, the drift velocity of the charge carrier directly proportional to the applied electric field. So I am writing here Vd is the drift velocity of the charge carrier that is proportional to applied electric field. Now in the above equation, we replace the proportionality with a constant that is called as Vd is equal to mu into E. Vd is equal to mu into E. This is equation number 1. Now in this equation number 1, where mobility is a constant, this constant, this mu is a constant, that constant term is called as a mobility. That constant term is called as a mobility of charge carrier. Okay, now we know equation for the current density. I am writing equation for the current density is equal to, it can be written using J is equal to Ne into Vd. Now let us say this is equation number 2. Now in this equation number 2, substitute first equation and second equation. What will get? Current density J is equal to Ne into, what is the meaning of Vd? Vd is equal to mu into E. So J is equal to Ne mu E. Okay, now I am writing this equation in terms of both electrons and holes. Why? Because it is intrinsic semiconductor which contains two types of charge carrier, that is positive charge carrier, that is electrons, and negative charge carrier, that is electrons and holes it contains. Therefore I am splitting this equation in the form of two parts. So J is equal to Ne into mu. What is the meaning of J? I am writing equation for the current density due to the electron concentration. So Jn is equal to Ne into mu n into capital E. Similarly, current density due to the holes is equal to PE into mu PE, where in this equation where n is equal to number of electrons, where n is equal to number of electrons, mu is equal to mobility of the electron, E is the charge of the electron. Then coming to the another equation, Jp is equal to current density due to holes, and P is equal to number of holes, E is the charge of the hole, and mu P is the mobility of the hole, and E is the applied electric field. Now I am writing equation for the total current density. I am writing equation for the total current density. Writing equation for the total current density. J is equal to, I am equating, not I am summing Jn plus Jp. What is Jn? The above equation, Ne into mu n into capital E, plus in the place of Jp I am writing Pe into mu P into capital E. Now in this expression, small e and capital E is a constant common term, so I am taking the outside. So J is equal to small e and capital taking outside. So what is the balance? N into mu n plus P into mu P. This is the expression. Now what we need? Equation for the current density we need. We know total, we know current, we know equation for the current density. J is equal to, I am writing equation for J is equal to, what is the previous equation? J is equal to E into E, N mu n plus P mu P. Now I need equation for the conductivity of semiconductor I need. So conductivity is equal to sigma is equal to J divided by E. What is the meaning of J from the previous equation? E into small e capital E into N mu n plus P mu P divided by capital E. Capital E is going to become cancel, and sigma is equal to, what you can write? Small e into N mu n plus P into mu P. This is the expression for the conductivity of intrinsic semiconductor. Now this is the expression what we need. So sigma is equal to, sigma means what? Conductivity of intrinsic semiconductor. Sigma is equal to E into N mu n plus P mu P in this equation. Now remember carefully, my dear students, terminology is very important, so to know about the equation. So in this equation, sigma is a conductivity. Sigma is a conductivity of what material? Conductivity of intrinsic semiconductor. Conductivity of intrinsic semiconductor, and E is equal to charge. E is equal to charge of charge carrier, and n is equal to number of free electrons which are available in the conduction band, and P is equal to number of holes in the valency band, and two more terms are balanced in the above equation, mu n comma mu P. I am writing combinedly. What is the meaning of mu n? Mobility. What is the meaning of mu n? Mobility of electrons and holes. This is about the above equation. Already we know that in the case of intrinsic semiconductor, intrinsic semiconductor, we know that number of electrons is equal to, we know that the case of intrinsic semiconductor, number of electrons is equal to number of holes is equal to Ni. What is the meaning of Ni? Intrinsic number. Now use this equation in the above expression. Sigma is equal to small e into, the place of n what I am writing? Ni into mu n. In the place of P I am writing Ni into mu P. Now take Ni outside, So sigma is equal to n suffix I into E into mu n plus mu p. This is a expression for the intrinsic conductivity in the case of intrinsic semiconductor. This is about intrinsic conductivity. Okay. Now you can write the same expression as it is in the examination. You will get full marks. Okay, we can also write the same expression by substituting Ni also. What is the meaning of Ni? Intrinsic concentration. Already we discussed it from the intrinsic concentration of charge carriers in the last presentation. I am substituting that equation here. Ni is equal to Nc into Nv. Ni is equal to Nc into Nv whole power 1 by 2 e power of minus Eg divided by kBt into what is the remaining terms? E into mu n plus mu p. You can write both the equations. Either you can write this equation or you can write this equation. Both are equations for the conductivity of intrinsic semiconductor. This is about intrinsic conductivity in the case of intrinsic semiconductor. In the upcoming session, we will discuss about the calculation of effect of temperature on the Fermi level. We will discuss the topic in the upcoming session. Please subscribe my channel and click the bell icon for getting regular updates in order to get continuous information regarding the total engineering physics. Thank you for watching this presentation.